Okay, we're going to go ahead and get started with the torus now. So let's just do a couple quick things in here. One thing I didn't do is wire these into controllers. So I think actually what I'm going to do is just put down control stops here and choose this to custom, wire that in, and then we'll give that the color as well of yellow. Do the same thing over here. And make that red. Okay, I'm just going to reset our transforms. Now we'll set up a torus here. So we have a number of different ways of doing visualizations for this. I'm going to do just a real rough one here, and you can choose whatever method of visualization you want. It can be a little funky to see this many polygons and stuff around here, so you can choose kind of what works for you. You can do something like, columns or rows and columns or rows or whatever actually makes the most sense to you. This isn't necessarily a bad one. Anyway, a bunch of different ways that we can do this. I'm just going to keep this on rows and columns, and we'll just copy from there. Pop down an NSOP. And I'm going to skip the transforms because we're going to do something different with that. I'm just going to copy paste into the control here. And what we'll do actually is give us two different tori to use. And let's go ahead and switch this to torus. So what we'll do is we will map the inner value to the radius of our inner torus. And we'll map the outer value to the radius of the outer torus. So that's going to define our torus like that, and then the actual scale of our torus will define something like this, and see if this is good for us to use. That'll give us a kind of general mapping that we can use there. So I'm going to go ahead and save this asset. And then we'll start working on some of the math. All right, going into our subnet here, we'll just do the fall off math right here. I'm just going to I'll copy sphere to start with. Doesn't really matter, but we'll just start with that one. And we'll just change sphere type to torus. We're going to just comment out this line here while we're working. And I'm going to start something a little bit different here. First thing we need to do is basically flatten all of our points on the y-axis. So I'm just going to call this, make a new vector. And I'm just going to call this flat p. And that's going to be equal to that my position vector times 1, 0, 1. Okay, so now we need to basically get the direction to that vector as if it was a 1-unit vector. So that means we're going to normalize that. So we're going to say that I'll just call that direction vector if we want, or we can just keep it as flat p. It doesn't really matter, but I will just call that for clarity's sake direction vector is going to be equal to the normalized version of our flat position. And now our d is going to be equal to the distance of our position and our direction vector there. And now we have that working just like it needs to, and we'll just double check that everything is good. So we'll go ahead and just kind of move this around. I can see that torus in there. Let's go play with some of the controls. And we'll just move our main controller around here and just make sure that things are sticking where they're supposed to be sticking. And it looks like it is. All right, so we can go ahead and save this asset now. Before wrapping up this video, I wanted to show one quick case where we do get a false positive in here, which is if the center of our torus is sitting directly on a point in here. What happens is in here, the vector for direction just turns out 0, so that kind of fails. So the quick solution that we have for that is right down here, which is to just say that if direction is equal to 0, that the effect is going to be equal to 0, and that will take care of that little point that's right there.